All right. Number one. You have a graph in front of you. The graph in front of you has all the parts that a graph needs. It's got a title. It's got two axes. It's got a scale on the axes. It's got what the axes are measured in. The first thing I would like you to do is identify the dependent and independent variable and be able to explain why that is the case. After that, you're going to answer all 1, 2, 3, 4, 5, 6 questions of that graph. There is nothing new there. It is simply applying all of the vocabulary that you learned on the last one. If you don't remember, then you have two options. One, you can talk to your neighbor and see if you can puzzle it out. Or two, you can wait until I fill it in. Either way, this is going to be filled in about a minute and a half. Go. All right. Independent variable is what? Time. Why?
Because the depth changes over time.
The depth changes over time. Absolutely correct. Right now, time is passing for me, yet I am not underwater. Although sometimes I feel like I am underwater as I wait for my class to answer easy math questions. See what I did there? Okay. The dependent variable is then depth. Absolutely. Why is this graph misleading to your senses? It goes up. And where does depth go? Down. Why is that okay?
It's a graph that shows if the depth is going up or down.
It's showing data. Is it drawing what happened? No. You must get that through your heads. You will all look at me and nod right now and say yes, but I will be crafting questions that will make you draw things wrong. Pay attention to what you are doing. Okay? Okay. How many minutes did the dive last?
29.
No.
17. No, 18.
28 minutes.
Feels like 38 minutes. Underwater. 30 minutes. Why?
Because the line ends after 28.
The line returns to a depth of 0 at 30 minutes. Why did some people say 29? Because it's the number right after 28. Without checking to see that each square was worth 2. Hey, boo-boo. You are all smarter than the average math student. So you should have the... It is a bad impression of Yogi Bear indeed. Do not leave your picnic baskets. No, that's Smokey the Bear.
Who's that?
The one that
They
lives
both
in the
like
forest
bears.
that fires are
They will talk. You.
There's Clipper.
Yes, but one is
Where's the dog?
admonitive, and the other one is just, hey, how's it going?
What about Yogi Berra?
Now, Yogi Berra was a baseball player. That's why Yogi Bear got that name. Because Yogi Berra said stupid things. Like in one interview, he said, half of this game is 90% mental.
Okay.
Which means, of course, that 45% of the game is mental. But that's not what he meant. Now, at what times did the diver stop her descent? How many of you automatically thought the diver was a man? Put your hands up. Yes, you did, you liars. And you saw her. It's kind of like that joke. Skydiver's parachute doesn't open, turns into a pancake, goes into the hospital, and the surgeon says, I can't operate on this man. He's my son. Or he's my daughter. I can't remember. And
My father had died, and then it was like.
it's because everybody thinks the surgeon has to be a man. Can't remember how the joke really goes.
There was like a plane crash, and the dad dies, and then the.
Yeah, I don't remember how. Yeah, the dad.
Oh, it's a stepfather.
Yeah,
It's
yeah.
like-
That's what it is. Yeah.
The men had an
Yeah.
affair, like
Yeah.
they're adopted.
Yeah. All right. So, at what times did the diver stop her descent? Pardon me? Not at 14 minutes. At what times did the diver stop her descent?
Oh, the first one is
This isn't lawyer ball, man. When was her descent stopped? It's right on the graph.
4 to 10, and then they go up to 20, and then she doesn't go any deeper than that.
So it's 10.
No.
Wait, I think that's what the line is.
4 to 8 minutes. And Sukmin, 10 to 14 minutes. Why did you know that? What does that mean?
But they're dead.
She is not moving anywhere in depth. What does keep moving?
Time.
Time. Why?
Because time is constant.
Time never stops.
It's like superpower.
See what I did there?
What was the greatest depth to which she plumbed?
20 meters.
20 meters. Good. Everybody can read that part of the graph. How long did she spend at that depth? 4 minutes. Wonderful. Now, state the domain and range in both forms. One form is set notation, one form is interval notation. I am going to have an orange whilst I wait to ward off the scurvy. Because you all took Socials 9, and you know scurvy is
I
bad
disease.
seed.
I learned more about
Bad seed. Yes, I know. That was a funny gag. I noticed nobody included me in the mean tweets.
Because you said you didn't want to be in the mean.
I know I said I didn't want to be in the mean tweets, but that doesn't... I also say I want my classes to do their homework. I also say I want you to be quiet when it's time to learn a lesson. I also say you should come to school every day. Do all of those things happen? No. So what I want is not very important to my student body. So I'm just saying I noticed that I was not included
That's
in the mean
because there's
tweets.
no mean things to say about
Oh.
Exactly.
Stop it.
I was thinking about they would actually be like the only two teachers. It was like Cavigia and Radnine and Mr. Reese. And Craig.
It was mostly bad now.
Yeah.
Yeah, we
Radnine
call them
was
a
the
dinosaur.
worst.
Yeah.
That was the most fun.
Okay.
Oh my god, they actually drew a 5 and saved us for your bracket. I got so
No,
far.
that's
Because when you did this, and you just like want to keep going.
All right. Who's going to tell me the domain and in what format?
It's been a few days, but
It has been a few days. Set notation you're going with, Byron?
yeah.
Hit me.
What's the
It's a metaphor, don't actually hit
set
it.
notation?
Interval notation.
I think this is set notation.
Okay.
0 is less than or equal to x.
is less than
X?
yes. Domain, right?
Yeah.
So time,
There you go. Time.
which is the x-axis.
There you go.
If I label the x-axis, do I still need to say time, or can I just?
Say time.
Okay.
Because
Okay. 0 is less than or equal to time, which is less than or equal to 28. Do you want the range as well?
less than or equal to
28. 29. 30.
30. There you go.
30.
What is that in interval notation? Square bracket. 0, comma, 30, square bracket. Excellent. What's the range?
Less than
0 is less than or equal to depth,
That's
which
the
is less
wrong
than or equal
one,
to 20.
Lauren. Because I'm paying attention. Ready? Perfect. That's what I did. Yeah, but we weren't on that one yet. That's what he asked for. I hope he was not.
Yeah?
Yep.
Yeah. All of you need to be able to read a graph. It took a little bit of time to get you to tell me when the descent stopped. Took a little bit of time for you to recognize that scales can change. Know what your weakness was and fix it. Yeah? Yeah. Next, reverse what you just did. There is a graph. Tell me what happened. But bear in mind this is only a math class. You will not be graded on whether or not your story has conflict, rising action, a denouement. None of that is important. Just tell me what happened. But that being said, a good story with some conflict, some exposition, some rising action, a little bit of person versus environment, person versus him or herself, little bit of that doesn't hurt because I got to read 30 of these. Go.
We're handing this in.
No. But eventually you're going to write a test.
Well, okay.
And this will be on the test.
Could very well be since it's material I'm teaching you. See what I did there?
Yeah, I saw you
I was scratching my neck with a ruler. But that wasn't what I meant when I said see what you did, see what I did there.
Oh, I know.
I'm going to turn my light off. No, I'm not. I'm just going to do this. What is the least amount of sentences your scenario needs?
One.
You could do it in one sentence if you punctuate correctly, yes.
Oh, can I?
But if we were doing basic subject, verb, object sentence,
Can I tell my story?
how many do I need? 3. Excellent. Go, Taylor.
Am I allowed to tell my story?
Please do, Taylor.
Alright, so for this example, I just used me as the person.
Of course you did.
Alright, what is that supposed to mean?
Why wouldn't you use
Oh,
you?
I don't know, I thought.
It's autobiographical.
Alright, so, I was filling up my watering can, so that's why it goes up gradually. So it was semi-full already, so then I fill it up all the way, and then I walk over to my garden. That's why I don't splash any out, and that's why I don't do anything. And then I get to my garden and I empty it all out.
Oh.
Wow, you're amazing.
You just like dump it out onto the grass or something?
No, onto the flowers.
Once the
That's why it all
flowers die.
empties so quickly and so drastically.
Stop working. I think you should read Sarah's. I would recommend it.
Does everyone agree?
That makes sense.
Okay. Now, if Taylor gives that to me on the scale of 1, 2, 3, and 4, first of all, she gets a 4 for having the backbone to read it out. But in reality, is that a 1, 2, 3, or a 4?
3.5. 4. Because 4 is really.
Does that show a lack of understanding, a basic understanding, a full understanding, or an advanced
I
understanding.
can explain it in more detail.
I'm full.
I'm using this for example, for illustrative purposes.
Basic.
Had
Basic.
I known I was being graded on this, I could have done a better
Of
job.
course you would have, Taylor, but I'm just using it as a teachable moment.
All right, please proceed.
Because this would be a perfect example of a 3. How could she make it a 4?
Add math.
And
Draw a
mathematical
picture.
concepts.
It would be nice if she added some math. What would you say, could you say about that section other than she filled up a half full watering can?
Greased it. The water. Wait, 35.
Pardon me, Rose?
Fill up the watering can, which increases the volume.
Okay. Still a 3.
Milliliters of love and
She
joy.
filled up her watering can with half a liter.
Getting warmer. It's not a half liter, but
750 milliliters.
No, but
oh, 750 milliliters. Now we're getting warm. Now we're pushing 3.5.
Can I read my story? I think it's really good. I think
Good God, man. Byron has written a novel, ladies and gentlemen. Byron, yeah, go, because maybe it'll address the question that I am asking about
It
here.
kind of does. All right. The bucket glistened in the pale
Oh.
moonlight.
Wait a moment. Let's do this right. Let's do this right. Carry on, my friend.
Hold on. The bucket glistened in the pale moonlight, still as time itself, with 1 liter contained within. 30 seconds later, Sadie had emptied 750 milliliters of water from a garden hose. She heaved the water up, with vapor from the crisp, cold air contrasted with the natural warmth of her body visible. 40 seconds later, she gradually poured it into her tulips over the span of 20 seconds. Yeah.
Not bad. Not bad. It's getting warmer.
like her natural body heat.
Okay, now, what I am looking for is something along the lines of Byron had half of it, right? 750 milliliters over the course of 30 seconds, right? If he had somehow mentioned the rate, right? And he was fine here, and he did mention she emptied it, and he mentioned she emptied it quickly, but she emptied 1.75 liters in 30 seconds,
30 seconds.
right? So it was at over double the filling rate. You picking up what I'm putting down?
20 seconds.
No, it's 30.
70 to 9, yeah, in 20 seconds.
20. But there's 3 lines, but it's,
Yeah.
it's 20.
20. No, he's right. He's right. The point is, to get that 4, I got to see everything. Picking up what I'm putting down?
Yes.
All right. Now, could the smoke and mirrors of Byron's story have garnered him a possible 3 if maybe the math wasn't there? Could very well have. Right?
5 appears.
It's not going to fool me.
So they could have like
Hold on,
rated the math.
Oh, you weren't done?
Hold on.
Wait a minute. Dot, dot, dot.
No. I just hid it within it, right? So there was 1 liter contained in the start.
Yeah, you had a liter. I heard that.
Yeah, 30 seconds later, so 30 seconds later after she filled it up over the span of 30 seconds.
Oh, you did have it in there. Okay.
She
Okay.
emptied 700 milliliters of water
From the hose.
Yeah.
Yeah.
She heaved the water up.
Yeah, I got that. Yeah.
Carried it. 40 seconds later, she poured it into her tulips over the span of 20 seconds. That's all of it.
Okay, the only thing you were missing is the total. So yeah, you'd probably gotten a 4. Everybody cool?
For real.
What? Oh, good gravy.
Yours is even longer.
Go ahead, Kayla.
It was a dark and stormy night.
A bunch of the guys were sitting around the campfire. One of the guys said, "Hey, Billy, tell us a story." So Billy began. It was a dark and stormy night. A bunch of the guys were sitting around the campfire. One of them said, "Hey, Tommy, tell us a story." So Tommy began.
No.
It was a dark and stormy night. Go.
The trees whistled to the tune of the wind, the rain poured, and the clouds dulled the evening. The little boy's watering can filled under the eavesdrop, acquainted with the mess taking shelter under the rotten roof of the house that nobody cared to visit. Exactly 750 milliliters of water was spilled that day.
That day?
From the already liter full watering can. The storm stopped for a brief. Oh, should I forget to put the number?
Okay. Kayla, you got a 4. All right. Now, number 3. Take the 2 things you just learned and draw a graph. But listen to me. 1, draw this graph in pencil, because I guarantee at least half of you are going to make an egregious error whilst drawing this.
So look at everything very closely.
Go.
Don't trust anybody.
Yes, it's a real conspiracy. Put on your tinfoil hats now.
That's what the aliens can't read our
Time
minds.
is independent of hope.
It only need be sketched, but do your best.
Lord, I have proof that
Any of you taking science will probably not make the errors that I am foreseeing, but if you haven't done your science 10 yet, there's a very good chance you will.
Hey, I'm doing that right now.
But then stop. How long was it driving? Okay.
Will 2 minutes be enough?
2.5 and we've got a deal.
2.5. All right.
I was trying to say B with a P at the end.
Am I right? Am I right? Jack returns home, taking 2 more hours. Yeah.
I'm just a dog, kid. I don't know.
So many potholes in this grass. Can't be.
Okay.
That was pretty aggressive, Sarah.
Yeah.
1 minute.
No happiness.
All right. Bam. I'm smart.
You know, I'm gonna assume that deceleration and acceleration is not a thing.
Aye. What goes on the x-axis? Time. How is time measured?
Hours.
If I go like this, then it's right.
All right. What goes on the y-axis? What is that measured in? Excellent. At 0 time, how many kilometers has he traveled? 0. Excellent. What do you know about the time over the course of the first 2 hours?
He drove 70 kilometers an hour.
So, at 2 hours, he is 140 kilometers away. I have set my scale up in 25s, so here I am at 125, 150, 140. Now, since it was a constant speed, we can draw a constant line. And as Sam says, he drove 70 kilometers an hour. How did you know that, Sam?
Because it says for the first 2 hours of the trip, they traveled 140 kilometers. So that means, like if you split the hours.
140 km in 2 hours. That's not how we measure speeds. Of course, we measure them by the unit. So we needed what it would be over 1 hour. So since that's divided by 2, that is 70 km. Well done. Excellent. Now, what happens now?
He visits his grandma
For 1 hour, so out till 3, what is happening to his distance? Nothing. So it is a flat line. Why must I draw that line? Because time marches on, to quote Metallica. Okay. Is everybody Gouda to there? Wonderful. What then happens? Wait, let's make sure. This is A. This is B. What happens for C? Where is my next dot?
It doesn't say how
Goes
long
down.
It doesn't give you a time, you're right, so you have to make some assumptions here, yes?
Oh, I thought it was supposed to be.
No.
It goes down.
If he drove 70 kilometers an hour there, what is a fair assumption to make when we don't have his speed?
He drove 5, whatever.
He drove 70 kilometers an hour, but only for 50 kilometers, yes? So did he go a whole hour? No. So we're at 3, right? He's gone 5/6 of an hour, yes? So he would go 5/6 of 70. Agreed? And according to Sam, it has gone down here. Okay, there's C. What happens then? He stops for 30 minutes, so this must go here, correct? The whole thing takes 5/6 of 70 minutes plus 30. So close to an hour and a half, yeah? Okay. And then he goes home taking 2 more hours. So he has to get from here all the way home in 2 hours. So can it be the same as that? No. Why? Because he is taking more time to go less distance. So it must go down at less of a slope than that. Does everyone agree? How many people drew a graph that looks like that? If you finished. Okay. Everybody that drew that graph drew it wrong. Why? Now talk.
Is it distance traveled or distance from home?
Read the thing.
Draw an accurate distance versus
Distance versus time graph. So what had to happen here?
at a raise point, right?
It had to go up, flat, up. Because this is distance. This is displacement. And we are going to explain it in the giant blank space between the questions like we always do. Distance is scalar. Please highlight, underline, Mrs. Bad Crumble Cloud. I don't care. A scalar is a value with only a magnitude, which is a size. When you get in your car and you drive, your car, as you all know, clocks how long you have been driving in distance on what is called the odometer, yes? You may not have known that what is called, but that is indeed what it is called. How many of you have seen Ferris Bueller? At the end, what does Ferris Bueller... Spoiler alert, if you haven't seen the movie, plug your ears. What do they try to do with the Ferrari so they don't get their asses kicked? Harmon? They try to put it in reverse. Does it work? No. Of course they shouldn't have. But the point is, they're stupid teenagers. Ferris is portrayed to be brilliant, but he really isn't. He's no different than you or me when I was that age. Now, distance is scalar. It only has a direction. A size. For example, how tall am I? 5'7" 3/4 inches tall. You guys give me the 1/4 inch and let me round it to 5'8". That is a scalar because I am 5 feet 8 inches tall. Move your hands. I am still 5 feet 8 inches tall. Does everyone understand?
Yeah.
Because direction, height is a scalar. Everybody cool?
But how many? How tall are you?
Displacement is a vector.
What's the symbol for vector? It's like the big V and we look at the Kellogg.
And a vector is both a magnitude, I forgot the a magnitude and a direction. Okay? So, this graph is displacement because the direction changes. He went away and then he went home. Now that calls up this argument.
So these two are displacements, right?
Yes. How many directions are there in math?
2.
2. What are they?
Up and down.
No.
Left and right.
No.
Sideways, back.
No.
Right and left.
No. No. No.
X and Y.
No. I'm going to say it
Positive
slower.
and negative.
Positive and negative. Those are the only directions in math class. How many directions are there in the world to describe?
Like 1,097.
Infinite, right? So, math guys have all agreed on a few basic, and I shouldn't have said math guys, mathematicians have agreed on a few conventions. The conventions are as follows. Positive is up, away from your starting point, right, east, north, and that is pretty much all I can think of right now. Therefore, what is negative? Down, towards, left, west, south. Everybody understand? Now, because I'm a good teacher, you will now see an example of it. From your perspective. Okay? Ready? From your perspective.
Negative.
How far did I travel?
Negative 2 steps.
2 steps.
Stop.
You traveled 2 steps.
2 steps. How far have I been displaced?
Negative.
Negative 2 steps.
Okay.
Because you still
Does
traveled.
everyone understand?
What if you went the other
From my perspective,
You traveled 2
how
steps.
far have I traveled?
2 steps.
2 steps. How far have I been displaced? This is tricky. Positive 2. Right? Because from my perspective, I'm away from my starting point, and I went to the right. Is everybody good? How far have I traveled?
4 steps.
4 steps. How far have I been displaced?
Not 0.
0. Because I went positive 2 and negative 2. Does everyone understand? I love teaching the pre-dip kids because they only need to see that once.
Do you have to do that multiple times?
Never mind.
That's what he
How was
implied.
that
Again, he implied that.
Yes, of course. All right. Knowing what you know and paying attention to detail. Write another story.
Yes.
Go.
You did it, right?
Alicia's race. She speeds up and then she slows down. Why are you slowing down before you finish?
Here, I'll do another basic one, and then you can go into other novels with like Byron and Kayla. Hey. Alright, let's go.
I was gonna make an insult, but I don't want to.
I'm very sensitive.
She's going feet meters or miles?
Alright, I've got a basic story when you're ready.
All right. Take it away, Taylor.
Alright, so Alicia is at the starting line, and then all of a sudden the air horn or whatever they're using to start the race. So then she speeds up really quickly to 8
Meters per second. Nobody is moving 8 miles per second.
So 8 meters a second. And then she is like that for a little bit. And then when the race is over, she stops running abruptly.
Good
That's
solid 3.
Yeah, thank you.
How could she make it a 4?
All right, take it away, novels.
4 and beyond.
Oh, do you? Go.
Okay, so Alicia is running her race. Oh, it's not yet. She gets on the start,
Yes.
and then the gun goes off and the time starts. And in a span of 2 seconds, she increases her speed all the way up to 8 meters a second.
Perfect.
And then for 12 seconds, she maintains a constant speed of 8.
Excellent.
And then in the last 2 seconds of the race, her speed decreases from 8 meters a second to 0.
The math is correct. I would disagree with your phrasing.
Yeah.
What happened at 14 seconds? Why?
Stop.
She finished the race and slowed down,
Yeah.
right? If she stopped running, why didn't the line go straight downwards?
She would have fell over.
Time marches on, even if she ran into a brick wall. The speed from full speed to nothing is still a measurable amount of time with the right instruments. Does everybody get it? Please notice what was not mentioned at all. No distances and no starts with a D, ends with an N, has irectio in the middle of it. Right. No directions. Because we are measuring a speed, which is a scalar. She is going that fast. Doesn't say what direction she's going. Right? So, 0, origin to A is acceleration. Oops, too many L's. Got a little away.
Nice handwriting, Mr. Mars.
I have it 5 L's. No, it's in. Yeah, it's 2 L's. I still have those L's in there.
Everybody good? You should have noticed already that there is one direction in which you cannot draw a line on one of these graphs. What is it?
Well, like, if you start. Exactly.
Damn it! There's 2 directions that you can't draw a line on these graphs.
Left and right.
One is left. Why? You
Can't run backwards.
You can't go backwards in time
Well, not yet.
unless you have a DeLorean that's fashioned with a flux capacitor and is fueled by plutonium and can get up to 88 miles per hour, generating 1.21 gigawatts. Not gigawatts, like they said in the movie, gigawatts.
How many times have you seen that movie?
A million.
What movie is this?
And that's not enough times because it's awesome.
What movie is it?
Back to the Future, you dingus.
If I'm cultured in my traditional values.
All right. What is the other direction that you cannot draw a line if time is involved?
Oh no,
Nobody?
Down.
Close.
Down.
Vertically. You cannot have a line that goes straight up and down. If time is one of your variables. Yes.
So, okay, if you're measuring a graph of a baseball, alright, and a pitcher whips it against a wall, and you're measuring the velocity and the time. The second it hits the wall, let's pretend it doesn't bounce or anything, and let's say the velocity is instantly reduced to 0.
But it's not instantly reduced to 0. That's the point.
You like get one of those high-speed cameras and like slow
It will
down.
squish. In my grade 11 physics textbook, there's a picture of a very muscular man, topless for some reason, I don't know why, hitting a baseball with a bat. And the ball is curved around the bat. Because the bat is going into the ball. This has a velocity, which is a vector, because it's got a direction. This has a velocity, because it's going that way. When they meet, they can't stop. Same reason when you're driving in a car, you can play corners with your little brother. Because you want to keep going that way, but the car is going that way. When you go around a corner, you slam into the person in the back seat and mash their face into the window. Duh. Corners. Girls, am I right, Blake?
It's like that musical like ride on the peony. Like,
You guys all know that, right? Yeah, you play corners. Well, you're from a big family. Of course you do.
No, we don't play
Yes.
corners.
Yeah.
Wait,
Yeah.
what?
What is
okay,
corners?
well, going around that roundabout.
When you
No, in Jay-Z's song, The Life of O.J., that's her, they play the corners.
Now,
Corners, is that a
Dad, don't conduct
You guys.
your job, since everybody has been talking through all the instruction, must mean that you're ready to draw graphs for 5, 6, 7, and 8. Go.
For number 8, when it says draw position, like what's the position? Like where do you start from? Find out.
What do you think it is? If position is important, if it's named in the graph,
Yeah.
then is direction important?
No.
Direction isn't important.
It is important.
Well then, would it be a displacement or a distance graph?
Placement for the position.
Right.
Where's the position? Where's it?
You don't need it to say, because the position is your starting point. I'll do that example for you again. Does it matter where I am? No. 2 steps away. Positive 2 steps.
Go to school, but instead of wrap around it.
one half this time.
Guess you're going to need to figure that out, because like I said, everybody talked through all my instruction. So everybody must know what they're doing. Go. And as you can hear, a great many people are continuing to do so. Sooner or later is when I say, this is out of 30 with 10 seconds left. And then all the people that didn't do that say, and hand it in. It is indeed. All the way until midnight.
Wow.
Yes,
Wait, what?
So then what happens? That's in grade 8.
it is the 11th until midnight.
Oh, okay. I thought you said it was 11 o'clock till midnight.
No, it is the 11th until midnight.
My friend in grade 8, when we were talking about like Friday the 13th one time, and she's like, you know, it'd be cool if Halloween landed on a Friday the 13th. It was the funniest thing.
That's all right. I feel your friend's pain, because I was at my friends who are in a band in Seattle. I was at their show, and a band one of those guys lives in Sechelt. And a band I very much like is playing a concert in Sechelt on St. Patrick's Day. The guys whose band I went to see play in an Irish band. So I said to him, what did I say? When are you guys doing your St. Patrick's Day show? And I meant, of course, to say, where will you be on St. Patrick's Day? Because if they weren't going to be doing a show, since he lives in Sechelt, I was telling him that you should come to this band's show. But I said, when are you guys doing your St. Patrick's Day show? And he looks at me. When? Shut up, Jimmy. You know what I meant. Yeah. But I didn't. I just misspoke.
How high does a swing get? I got pretty high on the swing. 7. The height you get is twice the height of like the little base thing.
Please remember, ladies and gentlemen, do not lawyer ball yourselves out of this. I am looking for concepts. Just draw something. No, the tortoise didn't nap under tree. That's the point of the story.
The turtle keeps going. The turtles are quite fast.
No, they're not.
Yes, they are.
No, I had a turtle too. They're not quite fast.
They just don't care, but if you scare them, they can run.
I know that.
Mr. Myers, may I please?
Yes, please do.
Thank you.
Turtles could have gone pretty quick. They go slow because they think people can't see more. Yeah. I think that they're camouflage. They're also really dumb. They walk off things.
We froze our turtle in a solid block of ice.
Why?
We didn't mean to. It lived on the deck of our house, but because it was a turtle, we would forget about it. And it got super cold overnight one night, and it was in its pond, and it froze solid. We thawed him out. He was okay.
He was okay.
He was cold-blooded.
How did it breathe?
They can hold their breath a long time. I don't know. I just work here. We thawed him out slowly, and he lived.
Oh my word. Was it an awkward squirm when he came out? Or he just
He's kind of like,
Can I have a turtle?
I don't know. My God, it was just a turtle. Same way you can boil a frog and it doesn't know. If you put a frog in
it doesn't
a pot of water, it just boils. It doesn't get out.
It's like, oh look, I died.
Yes. Height versus time for a child swinging on a swing. What's on this axis? Time. What's on this axis? Height. At 0 time, how far is the swing? Where do I put the first dot? Right there? Right there. Okay, so this is the swing.
On my desk.
Or maybe 1 cent to 2.
It's not swinging. Why?
Because you haven't started swinging yet.
No, because that says the swing is sitting on the ground at 0 height.
Oh.
Oh, it starts at height.
Oh, if only everybody paid attention.
Well, I don't know. I had a swing that was literally
So, the first dot cannot be there. It must be a little bit off the ground. Excellent. As time goes on, what happens to the height of the swing? Harmon? It goes up and down. How far up does it go? A very little bit, right? I'm not talking about, Dad, I want an underduck. The swing goes from my butt sitting in it to my butt standing in it. That far. I lift my feet, I swing. How far? What happens to the swing? It goes up a very little bit, and then what? To what level?
the same level as
The exact same level it started.
unless something breaks.
Then what happens?
A little bit higher.
Goes up a little bit higher. What happens to the slope of the line? It must get steeper or flatter. Why?
Because it goes faster.
Because you are going fast. You are going through more height in less time. So it must look like this. Will it ever go lower than that?
Unless it breaks.
No, unless it breaks. Will it ever, no matter what they say, no matter what your big brother said when you were first learning to swing about how he knew a guy who once swung so much, he went all the way around.
My brother
Is
did
that true?
Everybody's brother did that. It's not true.
No, he actually did.
No,
No, like he actually did.
Remember the girl in the
died?
recess that every episode she tried to go over the bar and then finally the season.
No, like he
finale,
was so
she
light,
launched
he just
went
went
over.
flying over the
What
moon.
show was that?
You never watched Recess?
I'm pretty sure you just fly
Oh,
on.
yes. Okay, I didn't know what. Okay, I thought you were
I don't know, he said he did.
I feel like
I once went and saw a movie with Angelina Jolie, and then I thought she was too ugly, so I didn't bother spending the evening with her. I saw down the road with Scarlett Johansson sitting by herself eating popcorn, so I moved down with her and I put the moves on her, and then we went out for frozen yogurt. I said that happened.
And then she carried
Did
him
it?
up higher and later.
No. You know why it didn't happen? Because that's impossible. You know why it's impossible?
Because
Because I'm me and they're them. Okay?
I
No, I'm okay with it, you guys.
Hey,
I'm okay with it.
Mr. Myers doesn't know how you feel, right? Sorry.
It never will go around. At any rate, that's what it would look like. Now, what am I trying to avoid? The person that drew the swing this way.
it takes 12 hours to go around.
Because somebody always does.
Wait, we go back in time.
They swing so fast, they go back in time. They swing faster than the speed of light. Next one. What's down here? Time. What's here? Distance. What's the graph look like?
It goes up.
Up. And only up.
It stops for a bit because they gave up.
It never comes back down. Why?
Because you can't go backwards in distance traveled. And
Because they traveled 400 meters in a certain amount of time. Now, I did say it was a race. Is that a 1, 2, 3, or 4?
2. Because I don't like how
It's not linear.
So you're not just gonna keep the.
and it's
Sometimes
unrealistic.
people start where.
There you go. I would say that's a 3. Does it show full understanding? Yes. Distance is covered in a certain amount of time, and they did not do displacement. Full understanding, you probably start fast, slow down a little in the middle, and then sharp finishing kick, right?
Honestly, I thought it was 5 hours later.
Number 7.
This is the displacement.
it does say so in the question. What are some perils that this question is fraught with?
It doesn't tell you where you start or what kind of a shape it is.
Excellent. It doesn't tell you what kind of track it is. What if you were on a track that looked like this?
It depends on where you started at.
So this was, say, 175 meters, 175 meters. Then how far are these corners?
Really far. Not that far.
They're 25 meters, aren't they?
Yeah, that is pretty far. I think it was.
Right? So if I start, for example, here, what direction does it go? I'm going away from start, yes? So where would your graph go? Up, right? It's a straight line, so it would go up in what form? If I am moving at a constant speed. 1 second. Kayla,
Yes.
how does the graph start?
Okay.
I don't know, Mr. Myers, because I was talking to these four. Amshman, how's the graph start?
You have to draw height, what do you call it?
I don't know, because I was talking to these four. Sam, how's the graph start?
The graph starts at the origin.
Great, then what?
And then it goes up because it increases because it's like a 400, he's riding a 400 meter race and 400 meter track.
No.
So it goes up. So based on the amount of meters he goes up, that's due to the time he takes to go that many amount of meters, the line increases, and since it's drawing a displacement versus a time graph, that means it can go in that direction.
Okay, so start drawing. Goes up.
No, wait, no. You go time.
The point I'm trying to make is stuff is going on here. Shut your pie holes. Okay, I'm tired of it. I give you guys enough time to talk to each other. Okay, if you want more time to talk to each other, go elsewhere. Because you obviously don't need me. Okay? And the next time you argue for a half a mark, I'm going to tell you to hit the damn road. Because if you want that half mark, you'd shut up and pay attention. Okay? Because if you don't care what I have to say, I don't give a rat's ass what you have to say. Got it? Okay. On this track that we have drawn, which matters why?
Because it tells you the shape or away you are.
Right. This track, I got to go a whole 175 meters away at a pretty constant rate.
It also depends where you start.
So, yes, it does, very much so. 175. What happens there? Am I still going away?
Yes, for a little bit.
For a little bit. Am I going away at the same rate?
No, it really.
No, because I am only covering 12 and a half meters here, not 175. So what happens to my line? Very shallow.
Yeah.
What happens right there?
It starts going down shallow.
It's going back home, very shallow. What happens there?
Goes back up.
Back steep. Then what happens here?
Well, where are we starting from?
I started here.
It increases.
Then, yeah, it goes.
It goes up.
Once I get to here, where's it got to go?
Around the corner, so it has to go up a little bit.
It has to go up a little bit,
Oh, yeah,
And then
right?
and then
It matters on the shape of the track. The point I'm trying to make is it is not, damn it, this. And shape matters. What if the track was a perfect circle?
it doesn't matter where you start.
Absolutely. And your distance is always going to be the same, right? Perfect circle is like a straight line almost. Excellent.
So if it was a square track, it would be like.
Yep. All right, next question. Position time. It's not displacement. It's not distance. I didn't use either of the words that I used to teach you. Which is it? Why?
Because you're drawing distance from the.
Lauren.
Because it's your, wherever you are in relation to your
Yes, it is your position. If I get up and take 2 steps toward Sarah and Lauren, I have changed my position, yes? Therefore, since you care about my position in space, it must be displacement. If you only cared about the distance, it would be 2. Right? But it's not. It's 2 to the left, or 2 south, or 2 north, or whatever it is. Now, this will change for everyone, based upon what? What your route is, your method of travel, and quite frankly, how you measure it. North, east, south, west, or just distance from home. Goodbye.